Hello, now we're going to solve some logarithmic equations, and there are two different types of logarithmic equations. There's this family, where we only have log on one side of your equal sign. One side of the equal sign. So notice over here we have the word log, and over here we have a number. Okay, so whenever we have log on one side of the equal sign, we want to rewrite this as an exponential. Okay, and there is a nice handy dandy little formula that we're allowed to do this on. So if we have any exponential equation, some base raised to some power equals something else. So this is your standard exponential equation where this number is your base, this number, whatever, is a power, and this is something else. We can change this into a log by writing the log of the base. Okay, your blob goes here, and the triangle portion goes over there. And this works both ways. So notice I have log on one side and a number over here. So I'm going to take this and rewrite it as an exponential. So that becomes 3. Okay, so this is your box. This is your triangle. So 3 to the 4th power equals this equation of 3x minus 3. So now I have my variable here. Nice linear, I can solve this one nicely. So 3 to the 4th power, 3 times 3 times 3 times 3. So 3 times 3 is 9. 9 times 9 is 81. Equals 3x minus 3. Add 3 to both sides. 3x equals 84. And finally dividing both sides by 3. X equals 3 goes into 8 2 times with a remainder of 2, 24. X equals 28 is the answer to this log base 3 of 3x minus 3 equals 4. X equals 28. So when you have logs on one side of the equation, you rewrite it as an exponential using this handy dandy little conversion formula thing. Okay, so notice also we have a log in this equation. So here's one term with a log in it. Here's another term with a log in it. Okay, so we're going to have to combine, or rather condense, these two logs into one. So there's a property of logs that says subtraction becomes division. Subtraction of the logs is actually the division of their values. So this will become log base 2 of 40 divided by x plus 3 equals 4. So now I have it in that familiar form where I have log on one side and a number on the other. So I'm going to rewrite this as an exponential. So this is once again your base. This big thing is your blob, all of it, and this is your triangle. So that becomes 2 to the 4th is equal to 40 over x plus 3. So now I have no longer a logarithmic equation, but a nice linear equation. So 2 to the 4th is 2 times 2 times 2 times 2. 4 times 4 is 16. 16 equals 40 over x plus 3. So now I have to solve this rational. The way that we do this is by multiplying both sides by the denominator. X plus 3 over here, x plus 3 over there. So this x plus 3 cancels out, or divides out to be a 1. And over here we can distribute. So 16x plus 48 equals 40. And now I have a nice linear equation that I'd like to solve. So subtract 48 from both sides. A 16x equals negative 8. Dividing both sides by 16 gives me an x value of negative 1/2. Okay, so checking our answer, because it's negative, if we plug a negative 1/2 in here, we still get a positive 2.5, which is fine. We can take the log of a positive, but we cannot take the log of a negative. So that checks out. So when you have logs on one side, you need to condense them and then rewrite them as an exponential.